So hello everyone. So in this video I am discussing the AC parameters of common source MOSFET amplifier. So common source means the source is grounded, input is applied at the gate terminal and output is taken from the drain terminal. So this is the common source without RS. The source resistance is absent here, and this is the common source with RS. So source resistance is present. So first AC parameters with the most frequently asked AC parameter is the small signal voltage gain, that is V naught upon Vi. Next is the internal output resistance, that is calculated by replacing this output V0 from where this output is taken by a voltage VDC, and the current flowing across this is IDC, and we have to remove the input supply for finding out the internal output resistance, which will be from here, seen from here. This is the internal output resistance from here onward. Now this is the internal resistance, it is input voltage upon input current. Now, because the input is applied at the gate terminal, so input current is the gate current, right? And gate current is always zero in a MOSFET. And that's why the internal input resistance is infinite in a common source MOSFET amplifier. And same goes with the current gain also, that is the output current of an input current. So current is zero, so current gain is also infinite. So that's why there is no need of discussion of these two parameters. So we have to just focus on the small signal voltage gain and the internal output resistance. So let's start with the common source without RS. So common source without RS. So we have to draw the small signal AC model of common source MOSFET amplifier. So this is the input from gate to ground. This is the VGS and after GM-VGS. Source is grounded here, and this is R0, and you have the drain terminal, the load is connected. This is the load. This is the RL dash at in AC analysis. So this capacitor will be short circuited, and this D supply VDD will be connected to ground. So both these resistors will be in parallel. So it will be RL dash, just the parallel combination of RL and RD. And the voltage across it is V0, and current flowing across this drain terminal is ID. So this is the internal AC equivalent circuit of MOSFET, which is common for all configurations. This part, right? Now we have to find out the small signal voltage gain, that is V0 upon Vi. So what we can do, we can apply a KCL at this drain terminal, and the KCL will be V0 upon RL dash plus V0 upon R0 and plus this GMVGS, right? So if we apply KCL, so it will be V0 upon RL dash plus V0 upon R0 plus GM VGS is equals to 0. And this VGS in terms of VIN, we can see this VIN is equals to VGS, right? So it will be V0 and 1 upon plus 1 upon R0 is equals to minus GM and VIN. Now this is in the parallel combinated form, so we can write the equivalent parallel resistance of RL dash and R0 as 1 upon RL double dash, which is the parallel combination of RL dash and R0. Is equals to minus GM. So V0 upon Vi, the small signal voltage gain, is equals to minus GM and this resistance, which is RL double dash. Right, so this is the small signal voltage gain, and it should be clear that this RL double dash is the parallel combination of RL parallel with RD parallel with R, right? And now this is the small signal voltage gain GM RL dash, and this is the now if this R0, it is defined as 1 upon lambda into ID, right? This is the channel modulation parameter, and if it is not given, so we just consider lambda to be equal to 0. So in that case, R0 is infinite, which is in 99% cases. It is given, this channel parameter is not given, so we just simply write the R0 as infinite. So if it is infinite, and let's say this RD resistance, that is the drain resistance, also not present, right? This RD is also absent. So then this RL double dash will be simply RL, right? In that case, the small signal voltage gain will be simply minus GM RL. तो basically याद हो जाता है minus GM RL, common source without RS no result. But we should have a good idea that if these resistance are parallel, then we will apply like this, right? The parallel combination of these three resistance. So this is the small signal voltage in. Now the internal output resistance. So R naught is equals to VDC upon IDC when the input supply is removed. So the small signal model will be like this. Input is removed, so you can simply short circuit, and this is the VGS, the GM VGS. Source is down here. Sorry, यहाँ पर we replace this V naught with a voltage VDC, and the current going across this is IDC, right? And again current, AD current is flowing, so AD is equals to IDC. Now due to this short circuiting of input supply, we have removed the input supply. This VGS will also be zero, right? Right. And VGS is zero, so GM VGS, that is the current source, which also 0 ampere. So whole current is flowing in this resistor only, right? R not. So VDC upon IDC, that is the output resistance, simply R not. So this is the internal output resistance, which is we have seen from here. If we see the output resistance from this, यहाँ से this number, so that will be R naught dash. It is not the internal output resistance. It is R naught dash is simply parallel with this RL, right? Which is R naught parallel with RL. And if this R naught is infinite, then it will be simply this RL, right? So this should also be clear. So this is the common source without RS. Now we have to discuss the common source with RS. So common source with RS. So the small signal model has the input the source resistance is present, which is RS here, and the source level. And here is the load resistance. So now we can't apply a KCL at this drain terminal, right? Because of this source resistance, right? We have to go with the KVL only. And along this path, यहाँ से लेकर here, start a KVL, this R naught, and following this path. So we will apply KVL in this path, and the current flowing in this R naught resistor is ID minus of GM VGS, right? KVL, it will be minus V naught, then plus ID minus GM VGS, and into R naught, and plus this ID into RS, right, equal to 0. Now this ID current is flowing in this direction, means this is the minus ID, right? So simply V naught is equals to minus ID into RL dash, in ID in terms of V naught is minus V naught upon RL. So we will substitute this ID here, and this VGS. Now this we can see that input is not equal to VGS, right? This will be again KVL along this path, so it will be VIN is equals to VGS plus ID RS, right? And ID is minus V naught upon RL dash, so it will be VGS and minus V naught RS upon RL dash. And from here we can see the VGS is equals to VIN plus V naught RS upon RL dash. So now we will substitute these two values here, right? So it will be V naught is equals to slightly minus V naught upon RL dash and into R naught, right? And this will be minus GM. VGS is this one, VI plus V naught RS upon RL dash and into R naught, and again minus V naught upon RL dash into RS. So V naught and V naught, these two terms will be taken in the left hand side. So 1 plus R naught upon RL dash plus RS upon RL dash. So R naught upon RL dash plus RS upon RL dash, right? And it will be minus GMVI R naught and minus GMVI R naught, and this will be minus GM V naught RS R naught upon RL dash. So this is RL dash plus R naught plus RS, and this will also be here in the left hand side, so it will be plus GM RS and R naught and upon RL, right? So this is the output, and here this is minus GM VN naught. So now this V naught upon VI, the small signal will be given as minus GM R naught and into RL upon, this is the RL dash plus RS and 1 plus GM 1 plus GM R naught and plus R naught, right? So this expression that we have got is the small signal voltage, which obviously can't be remembered. Now, if this again this R naught is infinite, if this R naught is infinite, which in the 99% cases we can say, so it will be taken common from numerator and denominator, right? Then only we can put the infinite. It will be यहाँ पर minus GM RL dash and upon यहाँ पर R naught we have taken common here, and यहाँ पर when we take common R naught here, so it will be simply RL dash divided by R naught, then plus RS by R naught and 1 plus GM R naught and plus 1, right? Now we put as infinite, so these two terms will be these will be it will be simply minus GM RL dash and upon, यहाँ पर ये तो कैंसिल, ये तो जीरो हो जाएगा, राइट? और इसमें से ये वाला टर्म बचेगा GM RS से, और यहाँ पर ये 1 plus GM. This is the small signal voltage gain. If the R naught is infinite, minus GM RL dash upon 1 plus GM RS, right? Now one more thing. So this is the, if R naught is infinite, minus GM RL dash upon 1 plus GM RS. Now if this GM RS is very greater than 1, then this small signal voltage gain can be approximated as minus GM RL dash upon GM RS, right? Which will be minus RL dash upon RS. So this is the approximation result if this condition is true. So this is the good approximation. Right. Now the R naught internal output resistance. So internal output resistance, that is VDC upon IDC, input is 0 volt. Again drawing the small signal model, so it will be short circuit here. Then this is the VGS, and here this is the RS and upper. I'm replacing this output voltage with VDC and current point across this IDC. So यहाँ पर this is the IDC, so this will be IDC minus GM VGS, right? This is IDC minus GM VGS, and here also it is IDC. Now again, we have to go with the KVL and just stop, right? And this, because of this dot circuit, now VGS is not 0 volt, it will be again यहाँ पर V 0 plus VGS plus of IDC into RS and equal to 0, so VGS is equal to minus IDC and RS, right? This is the VGS minus IDC into RS. Now KVL when you plug, it will be minus VDC then plus IDC minus GM, and VGS is minus IDC RS, so it will be plus IDC RS and R0 plus IDC RS, that will be equal to 0. So VDC is equals to, now if I take IDC common, so it will be 1, not 1, it is R0 plus GM RS R0 and plus RS, right? This is the expression. So VDC upon IDC is the internal output resistance. It is this result, that is R0 plus GM RS R0 plus RS. This is the result that we got of internal output resistance. Now, if this R0 is infinite, then we can see that R0 internal output resistance will also be infinite, right? So this is how we can derive these results, and obviously we can't remember these results, these kind of results we can't remember. That's why we have to go in this form only, just draw the small signal model and go with the KVL or KCL, whatever is appropriate, and just substitute these values like this. Just substitute these values and just find out the expression. But standard result we can obviously, uh, which is the in the 99% cases, you can remember these results minus GMRL dash upon 1 plus GMRS, जो basically याद हो भी जाता है, but this basic form भी आना ही चाहिए, right? So this is the definition of common source MOSFET amplifier without RS and with RS. So okay, thank you.